Swayam Prabha. Digital India. Educated India.
So, welcome back. Now, oceanic convergence, as I told that the heavier crust, heavier oceanic crust, this older one, will slide under the lighter one to form the subduction zone. The plate underneath bends and produces deep oceanic trench, which has been shown here and which I was explaining in my previous sketches, that this is the portion which you will find and the deeper part, and these are the termed as the trenches. Further, another good example, that because of this phenomena or the process, we have the deepest part or deepest portion on this globe, which is the Mariana Trench. So, the Mariana Trench is almost about 11,035 kilometers deep. Okay, it is 11,035 meters deep, and this exists between the Philippine plate and the Pacific plate. Now, hazard related to this, coming to the Indian part, we have the trench area, or we also name this as an Sunda Andaman Trench or Sumatra Andaman Trench, or we call this as an Sumatra Andaman subduction zone, and we experience 9.3 magnitude and tsunami. This is an earthquake and tsunami in 2004. So, when we plotted the earthquakes, which we collected from the data bank, it shows very clear alignment along the trench. So, this is an Andaman Island over here, and this is a Sumatra, and the earthquake of 2000, this is in 2004, and another on the same day, after few minutes, another earthquake was been triggered, was here close to Great Nicobar. This is in Great Nicobar here. This small island is the Car Nicobar, and then you go further, this is an Andaman Islands. So, continental subduction, as we were talking about, that we initially had this configuration that one plate subducted below another one, and this was because we had an oceanic plate in front of the continental Indian subcontinent. So, continental crust now collided finally with the Tibetan plate or the Eurasian plate, and what we see is the rising up of the Himalayas. Okay. So, when two continental continents meet head on, neither subduct, because the continental rocks are relatively light and, like two colliding iceberg, resist downward motion, and finally what we see is that crust tends to buckle up, and this is what we see, that two plates are colliding and we are able to see the rising up of the Himalayas. Convergent margin or collision zone, if we take, that marks the closure of the former ocean. So, we also say that in front of the Indian continental plate, we had the oceanic plate where Tethys Sea existed before. Okay. So, we have Alps, we have Appalachians, we have Himalayas, which are the example of your convergent margin and collision zone. So, continental collision, so we do not see now the oceanic plate, this was older and not much is happening in terms of the subduction. Of course, because this plate was dragged below, we have some portion which slips beneath and the overriding plate, and resulting into the formation of the Himalayas. So this diagram explains that what we have been talking about, that initially we had the continental plate, and in front of the continental plate we had the oceanic plate, which was occupied or covered by Tethys Sea, and slowly as this movement progressed, subduction was there and we had volcanic eruptions also, but slowly this resulted the closure of the Tethys Sea, and finally what we observed was this phenomena died out because there was no oceanic plate or the source for the magma to come up, and finally there was a total collision which resulted into the formation of the Himalayas. If we look at in total the configuration of the tectonic plates which we have discussed quickly, then we have the different plate boundaries. I have talked in detail about this. So the rigid plates, what we have, there are three type of boundaries. So one is your divergent, convergent and transform. So if we look at in detail few of them one by one quickly, then you will be able to understand better. So we have divergent plate boundary, which here has been shown. There is a oceanic plate separation, where I told on that day that we keep on having the new crust added along the spreading centers, and the area which has been seen on the globe is your mid-Atlantic ridge, which covers a very large part. And then we have the rift valleys, and the best example of this is in East Africa, and I was talking about that there is a recent opening which has been experienced in this region in the eastern part of Africa. So we have rift valleys, volcanoes and the earthquakes. So earthquakes, in the previous slide also you will experience earthquakes, but these earthquakes along the divergent plate boundary or the boundaries which are just passing through will not be so deadly in terms of the magnitude and all that. And then we have trenches, where we have convergent plate boundaries between oceanic and the addition what we will see other than the trenches, we will have the volcanic eruptions, because we have one plate which is moving down, subducting below another one. So we have oceanic trenches, volcanic islands and deeper earthquakes. Over in the first two slides you may experience shallow earthquakes. Convergent boundaries, again between the oceanic and continental plates. Again you have volcanic mountains, because again we are having the plate which is going down, hence we have a source of material which is getting into the asthenosphere, and we have volcanic eruptions on the surface. But here the difference is only that we are having oceanic and continental. So oceanic plate is subducting below the continental. We will also see the trenches here, as we were talking about in the previous slide, where we are having oceanic convergence. Here also we will get the volcanic mountain chains, folded mountains and deep earthquake, as well as shallow earthquakes. Then another one is continental convergence. So one of the best example is your Himalaya, which we have discussed in detail. So right now what we see in the northern part of the India, we see an towering height or the mighty Himalayas, which is the result of the convergence boundary, continental convergence. So here we have a very thick crust, folded mountains and earthquakes. And as I told in the previous two, we also experience the shallow, intermediate and deep earthquake, whereas here in this case we will mostly experience shallow earthquakes. Then we have transform fault boundaries, mid ocean ridge transform. So, just we see a lateral movement along the faults and of course, the earthquakes, but the earthquakes will not be of very large magnitude. Then we have the similar transform fault boundaries which we see along the continents, and the best example is between the Pacific plate and North American plate. And one of the major fault boundary or the transform fault which has been which is seen because of the movement between the Pacific plate and North American plate is a San Andreas fault system. So, you have lateral transform fault and of course, you have shallow earthquakes experienced along such boundaries. We have the discussion we can have on that what exactly we understand about the hazard based on the GPS measurements here. Now, if you take this is a plate boundary here between the Indian plate and the Eurasian plate, and we all understand that there is a very like a threat from an earthquake in this region. And recently, as I have discussed already, that we had in 2015 earthquake in Nepal, but other than that, many research groups have come up with an hypothesis, and probably based on the numerical modeling, that whole front which extends for almost 2,500 kilometers will rupture in one single go. Now, what we understand based on the GPS measurements between the two plates is that you have between the point here in Bangalore, and with respect to that, this is the fixed point here which moves towards the Eurasian plate. The total convergence which has been measured is around 50 millimeter. However, this 50 millimeter is not same all along the arc here. It varies. At some places it is bit higher, some places it is bit lesser. But out of this 50, if we take almost 5 millimeter, like it's very little amount, just a 5 millimeter has been consumed by this plate. That is up to Himalayan foothills. What we see is that only 5 millimeter is been consumed from 50 millimeter. Rest left out is almost 45 millimeter. Now, from that 45 millimeter per year of convergence, that means there is a velocity. The Indian plate is moving towards north-northeast at an with a velocity of 50 millimeter per year. Now, out of that, around 20 millimeter has been taken up by the Himalayan range. So, when I say Himalayan range, then we include the Shivaliks, then lesser Himalayas and then higher Himalayas. So, almost 20 has been taken by this, 5 has been taken by the